Hey, did you know that lead pencils actually don't contain any lead at all?
That's right. Lead pencils contain graphite encased in a wooden covering. Graphite is nothing but carbon. In fact, carbon is found practically everywhere in your surroundings. It is present in the clothes you wear, the food you eat, the fuel in your car, and in the tissues of all living beings. No wonder, carbon is the sixth most abundant element in the universe. This lesson is about the different forms that carbon takes. By the end of this lesson, you will be able to explain the significance of carbon in our daily life, list examples of the occurrence of carbon in nature, define allotropy, describe the different allotropic forms of carbon. Carbon is one of the few elements that can exist free in nature. In the free state, carbon occurs as diamond, graphite, fullerene, and coal. In the combined state, it can be in the form of a gas. For example, carbon dioxide and carbon monoxide. Carbon can also take the form of a liquid in the combined state. For example, petroleum and vegetable oils. In the solid form, carbon occurs in ores such as limestone, magnesite, dolomite, and calamine. Allotropy is the property of an element that allows it to exist in more than one form. In each of these forms, the chemical properties will be more or less similar, but the physical properties will be different. The allotropes of carbon are classified into crystalline forms and amorphous forms. The black residue left when carbon compounds are heated is called amorphous carbon. Diamond, graphite, and fullerenes are crystalline allotropes. Coal, coke, wood charcoal, animal charcoal, lampblack, gas carbon, petroleum, and sugar charcoal are the different amorphous allotropes of carbon. In a diamond, each carbon atom is bonded to 4 other carbon atoms by a single covalent bond. This is why a diamond is a rigid, compact, three-dimensional structure and is very hard to break. It is a bad conductor of heat and electricity as there are no free electrons present in it. Graphite contains carbon atoms in hexagonal rings, and the rings in turn are joined together to form a layer. A series of such layers are piled one over the other. The layers of carbon can slide over each other because there are no strong covalent bonds between the atoms of 2 adjacent layers. Since graphite contains free electrons, it is a good conductor of heat and electricity. Fullerenes were discovered in 1985 by Robert Curl, Harold Kroto, and Richard Smalley, for which they were awarded the Nobel Prize for Chemistry for the year 1996. A fullerene molecule consists of 60 carbon atoms arranged in pentagons and hexagons, like in a standard football. Fullerenes are also called Buckminster fullerenes, as they are shaped like the geodesic dome designed and built by the US architect Buckminster Fuller.